Okay, really quick here. Just a quick introduction to dynamics. Um, so everything we've been doing with setting up forces and diagrams, it all still applies. So we call it dynamics. All right. Basically, dynamics is when the system accelerates. All right. So that's where Newton's second law kicks in. And rather than F net being equal to 0, F net equals the mass of the system times the acceleration of the system. And usually we do this as x and y. All right, F net y equals mass times acceleration in the y direction. Now, sometimes this could also be written as the sum of the forces in the x direction and the sum of the forces in the y direction equals ma. Right? And in the last unit, the right side of this equation always just equaled 0. Now we got to be a little more careful, right? It's not necessarily going to equal 0. Newton's second law often is also reported as acceleration of a system equals the net force acting on it divided by its mass. That does make a lot of sense to think of it like that, especially when doing just a simple calculation of the acceleration of the system based on if you knew all the forces acting on it in one particular direction, you could, easily figure out the net force, and if you know the mass, that's a good way to think about it. But most of the time when we actually solve these problems, we absolutely have to do it like this, with MA on the right and F net on the left. In fact, this is the way that Newton's second law is actually written in words. The acceleration of the system is directly proportional to the net force acting on it and inversely proportional to its mass, right? So this is more of a direct translation of Newton's second law, but this is the way we typically use it mathematically. Now, I'm just going to do one quick example here, just to kind of get your brain going here. All right. So I'm going to have a box, let's say a mass of 5 kilograms. I'm going to pull on it with a force of 10 newtons at an angle of 30 degrees. I'm going to have to get a new Sharpie here for these school videos, but this will work for now. Let's say the coefficient of kinetic friction is 0.15. All right. And I say, okay, I want to figure out what the acceleration of this system is, the magnitude of the acceleration. Well, clearly it's going to accelerate to the right, right? It's going to stay on the ground and have an acceleration in the positive x direction. So the first thing we're going to do is draw a force diagram, right? So make my coordinate system here. Now, word to the wise here, all right? This is an important note, all right? Word to the wise. I always make whatever direction it's accelerating in the positive direction. So it's going to the right, so I'm going to make the right the positive x direction. Y, I'm just going to make it positive up. All right, so let's draw the forces acting on it. We've got this 10 Newton force at an angle of 30 degrees. We're going to have a frictional force here. We're going to have gravitational. And we're going to have a normal. All right, now the normal force isn't going to just equal gravity here because we also have a vertical component to our angle drop. So the stuff we did last unit is very important because that tells us how things go here, right? It tells us how to balance out the vertical forces. We don't have an acceleration in the y direction, so the normal force plus the y component of the 10 newtons is going to have to equal the force of gravity, which is negative 50 newtons. All right. Now the next step was analyze x direction and y direction. So x direction, F net x equals ma. So in the x direction, I have positive 10 newtons times the cos of 30 degrees. That's a positive force minus 0.15 times the normal force. That's our force of friction. Those don't just equal 0. They have to equal ma, which is 5 kilograms times a. A is unknown. All right, so sum of the forces equals the mass times the acceleration. I don't have to do any sign shenanigans with a because I made to the right positive, the direction of the acceleration. Sometimes what I'll do is either above or below my force diagram or to the side of my force diagram, I'll make a little arrow, right? A little black arrow. I'll call it A, just to remind myself that this thing's accelerating to the right. All right. Now I'm going to look at the y direction. All right. I have two unknowns here. I don't know what the normal force is. Well, I do. It's going to be 45, but I'll come back to that. So let's go to the y direction. Now, I ran out of space, so I can't do it next to it, so I'll do it below it, which, you know me, I usually like to do it in two columns, then merge them together, but oh well. In the y direction now, I have Fn plus 10 times the sine of 30, which is going to be 5, right? Minus 50 newtons has to equal 0, right? Because ma in the y direction is 0. It's not accelerating in the y direction. So I solve this now for Fn. I get Fn equals 45 newtons. That comes over here. This is 5, so 50 minus 5 is 45. So now I can plug that in up here. All right. So 10 times the cos of 30 is like, oh boy, 8.7 I want to say. I didn't bring a calculator over with me, but I just did this problem for the class, so I think I remember the numbers. Then minus 0.15 times 45 equals 5a, so I drop the units. I think this ends up being 6.8, because then this ends up being 1.9 equals 5a. 1.9 over 5, 1.9 over 5. 5's cancel. You get a is equal to 0. Oh boy, I don't have it on me here. Calculator. Pause this for a second. It ends up being 0.38. I should have estimated it, right? 2 over 5 is 0.4. All right, phone's about to run out of space here. Units are meters per second squared. All right, so basic dynamics question. We're going to take a look at the multi